So this is section 1.4, I hope. Okay, so what we're talking about is we're going to talk about inductive and deductive reasoning. So if we went and checked a bird's nest and we saw blue eggs, and then we went and checked another bird's nest and we saw blue eggs, and then we went and checked another one and there's blue eggs, then we would think all birds have blue eggs. Okay? So that's not true because there's chicken eggs. Only bird that has blue eggs is a robin, I think. But we just happen to see 3 nests with robin eggs. So what I just explained is inductive reasoning. It means you tried it and you found something, you tried it again, you found the same result, and then you tried it again, got the same result. So that's inductive reasoning. Okay? Doesn't mean it's true, it just means you found a pattern and then you assumed it's true for the whole thing. Okay? So the other one is deductive reasoning, and deductive reasoning is when we solve something mathematically and then it proves it's true for the whole time. Okay? So in this case it says John discovered a pattern when adding integers. He claims that whenever you add 5 consecutive integers, so consecutive is in a row, yeah? Yeah. When he claims that whenever you add 5 in a row, the sum is always 5 times the median numbers, or the median of the numbers, so that's the middle of the numbers. Okay, so in his first example, hold on, I'll move this. Oh, I moved it too far. We can kind of see it. 1 plus 2 plus 3 plus 4 plus 5 is 15. Okay, and so what he found out is he's saying that if you took the middle number and multiplied it by 5, that's your answer. Okay, in that case, it worked out, right? 3 times 5 is 15. Okay, so if we had some more consecutive numbers, minus 15, minus 14, minus 13, minus 12, and minus 11, and we added all those up, we get minus 65. And if we took the middle number, which is minus 13, and we times it by 5, we get minus 65. So it worked out again. Okay, and then if we tried it again, minus 3, minus 2, minus 1, 0, 1, the middle number is this. We times that by 5, we get minus 5. Okay, so it worked out again. So he says that this is true for all integers. Okay, so what we just did here is inductive reasoning. We tried it, we just picked some random numbers, it worked. We tried it, pick some random numbers, it worked. Tried it again, pick some numbers, it worked. Okay, that's inductive. So then we assume it works all the time, which isn't true. Okay, sometimes it's not true. But so if we wanted to solve this deductively, what we do is we use the values of x in it. Okay, so say our numbers are 5 numbers in a row. So our first number is x, so then our next number is 1 more than x. So we'll call that x plus 1. Okay, because numbers in a row, they increase by 1, right? So then my next number after 1 more than x is 2 more than x, right? And then my next number is x plus 3. So I have 1, 2, 3, 4, and then we need 1, 2, 3, 4, 5. We got 5 numbers. Okay, so then if we were to add these all up, we have 1, 2, 3, 4, 5 x's, and our numbers are 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. Okay, so we have 5x plus 10. So if we divide out 5, what we find is we have our x plus 2, that's our middle number, and it's being multiplied by 5. So what we found out is the middle number multiplied by 5 will always give you the answer. And that's what John said. The middle number multiplied by 5 gives you what your answer was. Okay, and we found out, because this is the middle number, right? It's being multiplied by 5, so it's exactly what John found out. This is inductive reasoning, this one up here. This is deductive reasoning because we solved it using x mathematically. So that proves it'll work for any single number all the time. Okay? Okay, so example 2 says, Luke found, oh, where's the rest of the example? Oh, the difference between consecutive perfect squares is always an odd number. So consecutive means in a row, and perfect squares are something times something, right? Like 5 times 5 gives you 25. Okay, so in the textbook they go and they figure out 26 squared, and so they're saying the difference between two consecutive perfect squares. So if, say I have 26 squared and I subtract 25 squared, those two numbers are in a row, they're squared. Okay, I think this is 676. Somebody check it for me. And this is 625. So if we subtract them, we end up with 51. Okay, so it says, he says that the difference between consecutive perfect squares is always an odd number. And I got the answer of 51. Okay, so it seems that his theory is true. Okay, so let's try it out for all numbers. So if I said, here's a number, x plus 1, and I squared it, and here's my other number, it's just x squared, because they're in a row, x, and then x plus 1 is consecutive. Okay, so if I did that, and I'm running out of room, here, we'll go like this. Hold on. Okay, so if we look down here, come on. Okay, there's what I just did. We got 51. And so if we're going to prove it deductively, here's our numbers, x squared plus 1 squared minus x squared. Okay, so when we have x squared or x plus 1 squared, you have to FOIL it, right? Okay, so when you FOIL it, you get all of this, and it's subtracting your x squared. So what happens, you have x squared, subtract an x squared, those are gone, and then you have an x plus an x is 2x, plus 1 is a number, okay? And so what we need to know is, he said that you'll always get an odd number. So when we're doing proofs, the key to proofs is what makes something an even number. Does anybody know what makes something an even number? Yeah, because of what? Yeah, you can split it in half. So it means you can multiply it by 2. So when we're doing proofs, this is a key for you guys. You might want to write it down. Even numbers are always represented by like 2x or 2b or something, because 2 times any number is going to give you an even number, right? Because it has to be able to be split in half. Okay, so then any odd number, so if you think of how numbers go, they go even, odd, right? So you have an even number, one more makes it odd. So if I had 2a plus 1, that makes an odd number. Okay, so when we're doing proofs, we always consider 2a or 2x or something like that even. And when we say 2a plus 1, it's like an even plus 1 more, which makes it odd. So if you look here, we ended up with 2x plus 1. We ended up with technically an odd number because it's an even plus 1 more. And so this person, I can't remember who their name was in this, Luke, he said you'd always end up with an odd number. And we did. We ended up with 2x plus 1, which is no matter what we put in there, if we put 10 in for x, 2 times 10 is 20 plus 1 more is 21. You're always going to get an odd number. Did everybody get that copied? Okay, so example 3 says, all dogs are mammals, all mammals are vertebrates, Shaggy is a dog, what can you deduce about Shaggy? Okay, so these ones are best done in a Venn diagram form. Okay, so it says all dogs are mammals. Okay, so if I was a dog, I would have to be a mammal. Okay, so it's not saying that all mammals are dogs, right? But if I'm a dog, I have to be a mammal, so I'm encompassed by the whole mammal part. Okay, so I could be a different kind of mammal. I could be a cat, I could be a whatever. But a dog has to be a mammal. And then it says mammals have to be vertebrates. So another circle around this is for vertebrates. Because in order, vertebrate, I don't know if I spelled that right. So in order to be a mammal, you have to be a vertebrate. So vertebrate encompasses the mammal. So what can we deduce from this Venn diagram about Shaggy? Because we're saying Shaggy is a dog, so what else is Shaggy? Shaggy is a mammal. And what else? And a vertebrate. Well, we already said Shaggy's a dog in the statement. Okay, so the question was, all dogs are mammals, all mammals are vertebrates, Shaggy is a dog. So since we're saying Shaggy's a dog, then we are also saying Shaggy is a vertebrate and a mammal. Okay, so that's a Venn diagram.